So, all work, no play doesn't scale. Scaling is a very loaded term. It means many things to many people. But today what I'm specifically referring to is development productivity. How quickly you can develop a web app, or any sort of app, and get it going, and how it supports you in doing that. And a lot of frameworks, web frameworks, you have to do a lot of stuff for yourself. But with Play, a lot of things come out of the box. So, what is Play Framework? Play Framework is a framework for writing web applications that lets you write them in Scala or Java. We're going to look at Scala today, but it does have a Java API in case you're interested. It supports, a big focus of it is fast development loops. So you shouldn't have a compile deploy cycle where you have to run a command and then go away and have a sword fight on a couple of chairs. It supports asynchronous I/O, and this is not just well, if you go into this special mode, it's async, but it's async right from the at the very core, and everything that you do in it is very asynchronous. It uses an asynchronous iterate API to handle streams, and the features are all throughout the API everywhere. It has first-class support for the modern web. Okay, so what I mean by this, modern web standards such as WebSockets and server-sent events, these are built right into Play. Using these is just like writing anything else in Play. There's nothing special about it. It just supports these. Front-end technologies such as Less, CoffeeScript, Require.js, these are all come out of the box. You can just use them. You don't need to worry about having to set up compilers or anything like that. It should just work for you. And also JSON is a first-class citizen. This is very important because a lot of web development that's done these days is doing REST APIs. And in REST APIs, the most common data format is JSON. So having JSON support as a first-class citizen is very important if you want to be productive doing REST APIs. Now, as I said, this is about getting on with the development and not doing so much work. And I don't really like writing slides, so this is actually my last slide. So let's get on with the playing. It's not the end of the presentation.
I just don't like slides either.
Okay, so what we're going to do is we're going to write a new app. So I'm going to create a new app called Feedback. It's going to be an application for leaving feedback. So if I go to the feedback folder, I've now created a new application. I'm going to start up the Play console, which as an SVT project, the first time running might take a little bit of time. After that it's much faster. And the first thing I'm going to do is I'm going to open in an IDE because I need some help. And then I'm going to run it. So in my IDE, I'm now going to open this project. And I'm also going to view the run application. So while it's compiling, we can have a look here and we can see the structure of the project. The main source folder is called app, tests go in test, there's a configuration folder, and we have a few files around the place. So
you
this...
have to run any particular command to get IDE support, is that right?
I just ran IDEA before.
Okay, I did so.
So here's my new app. It looks pretty. You can see it actually gives you instructions for what you can do next, explains what you'll find when you look in the IDE, tells you how to set up the IDE, database, and in fact you can even do this if you're on a plane because the documentation is right there for you, served by Play. So, but I'm talking about it today, so we don't need to look at the documentation. So why don't we have a look, how is this index page served? So if we have a look here, the entry point for a Play application is the routes file. And routes declares a set of routes from HTTP methods and paths to what we call actions. So you can see here when you do a GET request on /, it goes to controllers.application.index, and we can open that up. So application extends controller. There's nothing special about this application object. Controller is basically is a trait that brings in a whole stack of helpers for building results. It doesn't have to extend it, it just makes it easier. So we can see this index action. It's declared to be an action, and it returns a result that's OK, and it's calling this views.html.index, which is actually a template, and that template is implemented in Scala. So, and it's passing a parameter to that template. So we can go and have a look at that template here, and this is a template language that's part of Play called Scala templates. Anything that's after an is special and is usually some sort of Scala code. So the first line here declares the parameters for the template. You can see we take a single parameter, which is a string. They can be curried parameters, you can have implicits and stuff like that. Here we have calling another template. A template is basically just a method. And this is calling the main template, which you can go to here. As you can see here, the main template takes a string parameter and then some content. And so we're invoking that there. Here's the content, which is kind of a sub-template. Then we have, we're using the Play2 welcome helper. That just gives us the pretty Play2 screen. So one thing to say about all this, these templates are compiled to Scala code. That means that they're type safe. So if I was to change, if I was the welcome template, or if I was to pass here an integer, for example, IntelliJ thinks it's wrong, and we can have a look in here, and Play should recompile it, and we get a compilation error because these are type safe templates. Another thing is the routes file is also type safe. So here, this is the routes for assets. If I was to try and pass 1 to here where it accepts a string, again, we get an int, but we required a string. So you can see here that, that our routing and our templates are strongly typed. And you can also see when there is an error, you get a nice message in the web browser, and you can see that whenever I make a change, it automatically recompiles and does that for me. And of course, the same is true for the Scala code. So if I was to put a syntax error there and hit refresh, it shows me the syntax error and gives me some context around it.
Is it the refresh that actually sort of kicks off the compile?
It is the refresh. There is another way to run it where it'll scan every second for changes. But I like to...
Because it's sort of got some sort of hook into the GD or whatever it is.
Yeah, it's monitoring the file system. Yeah. Or it's the back end is Netty. Yeah. And yeah, Play is implemented that itself to kind of integrate with SBT and everything like that. Okay, so let's start writing our feedback application. To start off with, I'm going to modify the main template to do this. So I'm now printing the title as a header, and I'm wrapping my content in a div. That's just for some styling later. And I'm also, I don't want this welcome to Play2 thing. I'm going to putting an internationalized message with a feedback key, and we don't need the Play welcome string. So let's see what that looks like. It should be very basic now. We can just get our feedback. We haven't defined a messages file yet, so we're just seeing the raw key.
You had a type called messages, was it? But,
it
wasn't a string yet.
So messages is an object, is the messages object for looking up messages for the current language. It takes an implicit language parameter So
you changed your main before as well, though. So that was taking one of those.
it returns a string.
Oh, okay.
Yeah. Okay, so the next thing I'm going to do is, this is an application for leaving feedback and displaying feedback. So we need a model to model that feedback. So I'm going to create a model called feedback. We'll make this a case class, and we'll have some parameters. So we're going to have a username and the feedback. Very simple, just 2 parameters. And this is how we're going to model our feedback. So the next thing we want to do is we want to model this feedback as a form. Now, in Play, everything tries to be as type safe as possible. So there's no reflection. So when we want to do a form and bind stuff to a form, I've just added some imports there that are going to help me with this and with things in future. We use this this mapping function. So there's Play has a form object, and we can declare that this form has 2 parameters: a username parameter, which is non-empty text, so there's actually some validation in there to make sure it's non-empty, and a feedback parameter which is also non-empty. And then we bind that to the apply and unapply methods of our case class, which means that without using any reflection or anything, with compile time validation, we can bind this form to our feedback model. Okay, so we'll start off by just...
So non-empty text, that's a validation.
That's a validation. Yes.
So
there's a number of validators, including email, integers. You can specify a range of integers, dates.
So what is the type of that expression, username, arrow, non-empty text?
I believe the type would be mapping. Yes.
Mapping, right. Mapping to string, right. Yep.
Yep. So yeah, it's a tuple, and we pass into this a tuple of parameter names in the form to mappings, and then that allows us to bind it to and from the case class.
So now it can actually match that up against the fact that feedback has 2 string parameters and it all type checks. Yep.
Yep. And of course, because there's a limit of 22 arguments to a Java method, and because there are some other parameters, the maximum number of elements that you can have in a form is 18. But if you have a form that's got more than 18 parameters, you've got to really be asking yourself, is this very user-friendly? Yeah. But you can get around it by having sub parts of the form and binding it to multiple objects. And it's not too bad. So let's, to render this form, we're just going to pass it as is into our index. That's obviously not going to compile, but that's okay because we will change this to accept a form parameter. So the type is actually form of feedback, and we're going to have some an import to import some helpers, and we're going to have some HTML. So these input text are helpers that Play provides for rendering fields in forms, so that'll also handle rendering the error messages and things like that for you. And we're passing the username field of feedback, the feedback field of feedback, and we've got a submit button. Obviously this isn't going to do much yet because we haven't defined an action for the form, yep.
Just before you go on, would you better just repeat what you just did where it all just blitted into existence?
IntelliJ live templates. They are, I've set them up for this presentation so that I don't have to type, so you don't have to sit there waiting for me to fall around.
Not a copy paste.
So you said the input text that it handles errors and everything. Does that mean it provides classes so you can style your errors?
Yep. So you can pass extra parameters to. Yeah, it does have classes built in that you can use, but you can also pass in extra parameters to it to customize that And in fact, there is an implicit parameter passed there called a field constructor, and you can define your own field constructors that will do all that rendering for you. Yeah.
So that's let you just call any Scala code at all, and just whatever the string response is, that's it to the page?
Pretty much, yeah. Yep, you can define methods and stuff like that as well.
Cool.
Yeah. Okay, so let's have a look at what our form looks like now. And I have to explain why it's slow. You're all Scala developers, so you understand. Now we have our form. As you can see, it's marked it as required, and it's not very pretty. So let's make it. We've still got the internationalization keys there. So why don't we define a messages file for that? So this is just. We can define multiple messages files for different languages. Today all we're concerned with is English, and this was a lot more impressive when I did it in Japan and it came up and it was all in Japanese. But for now it's just English, and you can see we're now internationalized. Okay, so why don't we implement the ability to submit feedback. So what we're going to need is a new action, and we'll call this leave feedback. So this time, this action actually takes a parameter from the request, because we want to read the form body out of the request. So the first thing that we're going to do is we're going to bind our form. So you can see this method here I'm calling feedback form.bind from request. And this takes the implicit request and binds the request to our form. We then fold it. So the first parameter, the first function here is the error function. And so if there was an error, then we're just simply going to pass the form back to the index. And that form object there, it's the same form of feedback, but this time it's populated with errors. So that will be able to render the errors. And then this one here is for handling if the form validated successfully. So what we're going to do, we're not going to worry about the database just yet. When receiving a form, you probably want to redirect so that if the user hits refresh, they don't double submit the form. So we're going to return a redirect result, and we're going to redirect back to the index. Now what I'm using here is the plays reverse router. So I said the router was Typesafe, but not only is it Typesafe, but it also generates a Typesafe reverse router. So I can refer to the index route here without ever typing a string with a URI. It means I can update my URIs, I can update the context that the application runs on, and my code can be completely agnostic to that.
They just replace controller with routes, is that, and everything else works?
Yeah, yes, something like that. So now I want to, because this is a redirect, I want to pass a status message to say that the form was successfully received. So I'm going to use the flash scope. And the flash scope in play is a scope that just lasts till the next request comes in, and it's designed specifically for when you're redirecting after a form submission. So we're now sending this flash scope of status, and we can then read that in our index. So we will need a request parameter there, and we can get that in our index and pass that to the index template. So go into our, sorry, yeah.
Where's that state kept?
It's put into a cookie, which is cleared on the next request. So in our index then, we will first we will first define that we can accept that, that status message, and we will also render that status message. And let's just check now that everything compiles fine. And it does. So what we want to do now is point our form at our newly created route, which actually means we have to create the route first. So here's a new route. You can see it's strongly typed, and we want to invoke leave feedback when somebody posts to slash. And I'm just going to recompile that again. So now we want to point our form to that newly created route. So again, we're using the inbuilt play helpers, which take allow us to generate a form. And again, we're going to use the reverse router. And so here we can say we're pointing to leave feedback, and that will use the correct method, so post for the form, and the correct action with the correct URI in the action. And you can see here's an example of adding extra parameters. So I'm defining the ID for this form, and the form helper needs to be closed like that. And so now we should be able to submit some feedback. And we can see we've got that status message now saying feedback left by JRoper. Okay, but before we get into the database, why don't we make it look pretty? So play comes in the template project. There's a style sheet there for you, which you can use. I don't actually want to use that because I want to do something different just because I can. I'm going to use less to create my style sheets. So for those of you that haven't heard of less is a way of writing style sheets easily, very similar to CSS, but basically you write less code. You can define variables and inheritance and all sorts of stuff like that. So I'm going to put this in assets/style sheets/main.less. Now, like everything else in play, this will be compiled, and if there's an error, which that should be an error, I should get an error. There we go. So you can see play validates that and you get a nice error in your browser.
That's the hard-coded location where it expects that less file to be, is it?
No, it will find it, anything that ends in .less. But you can control where it looks. So you can see I've just changed the title to blue. I'm not going to bore you with writing the style sheet, so I'll just generate it all, and it now looks a lot more pretty. So back to, so we now have a kind of pretty application. Something I didn't show before is the validation. So if I do send now, you can see I get that error message. And if I submit, it's all fine. So let's start talking to a database. What we're going to do first is configure play to talk to a database. So we're going to use H2 as our database, and we're going to, just for development, use an in-memory database. Because it's an in-memory database, we're going to have, when play starts up, we're going to have to create the schema each time. So we can do that in play using something called evolutions. So you can have multiple databases. We're calling it, the default one is called default. So we're going to define an evolution for the default database. So you can see here anything in the up section gets run when the evolution needs to be applied, and if the evolution needs to be backed out, then whatever's in the down section gets run. So now if we refresh, you'll see we get an error because our database is in a state where it needs an evolution. So it shows me what it's going to run, and we can now run this, and now our database is created. So let's go back to our feedback model. To start off with, I'm going to add a few imports. And what we're going to use for talking to the database is a database library called anorm. Now, anorm is not really an object relational mapper. All it is an object mapper that maps result sets back to objects. Basically, you can think of it as JDBC on steroids. There's no sessions or session caches or anything like that. And what it does is you define ways to save things, and you define mappings from result sets to your classes. So first thing we'll do is implement an insert method. And so you can see here we've implemented this. Now this could be inside a service, a DAO. I'm just doing it directly for this simple application on the case class. The way it gets a database connection is it accepts an implicit connection, and we will see how we supply that later. So we've got some SQL here that we defined, parameterized with these username and feedback values. We then map those values to those parameters to values from our case class, and then call execute insert. So to invoke this, we'll go back to here where we've got our successful feedback object, and we'll just call feedback.insert. Now we need that implicit connection, so Play provides a helper DB with connection, and that gives us the implicit connection. And IntelliJ doesn't like formatting things nicely when I do that. But now we should be able to leave some feedback. And this should all work. So that worked. But we can't see the feedback yet, so we don't really know that it works. So why don't we implement the method to be able to load the feedback. So we go back to our feedback model, and we'll define this in a companion object. And so we've written a find all method that accepts an implicit connection. So here we've defined an SQL statement, select star from feedback, order by ID, descending. So it's just an ordinary SQL statement. We've then defined a row parser for that. So we're expecting a parameter called username and a parameter called feedback. And that star you can think of as a regular, like in regular expressions, so it's saying repeat this over and over on every single row. And then finally we've defined the bindings for this, so the actual result of this is a fairly complex type, but Flatten turns it into a tuple, which we can then map to the tupled version of our feedback.apply method. Now at this point here where I've got the cursor, the statement hasn't been executed. Sorry, the statement has been executed, but we haven't read any results yet. You can iterate through these results and it'll pull them from the database as they come, but we're just for now interested in just taking the first 10 results. So take 10 will return an actual list of the results. Okay, so let's start using this. We want to pass this feedback into our feedback form, into our index view. So we'll call feedback.findAll there, and of course in our index method we don't have a connection yet, so let's define an implicit connection like we did with the leave feedback method. And we'll also, when we have an error, we also need to pass our feedback there so that it renders nicely, because we're going to change the signature of the index template. So we'll change the signature now, and we're accepting all feedback, and now we'll render that feedback. So here you can see a for loop in Scala templates, and it looks very much like normal Scala. And so now, if we have a look at that, we should see our feedback. And there it is. Okay, so now we have the basic application working, but let's get on to some more complex stuff. When I'm looking at this feedback, I don't know if the user that left the feedback is worth anything. I don't know if they have any influence over people. So what I'm going to do is I'm going to use a third-party service that allows me to look up the influence of somebody, and this service is called Clout. Now, I'm not sure if you heard of Clout, but it's a service that goes and polls Twitter and Facebook and finds out a user's clout, or their influence, which is represented as a score, which is basically how many people or how influential is this person according to their use of social media. As it happens, Clout actually implements their API, so the API that we're going to be calling in Play Framework 2. So that's kind of a nice plug there. So what we're going to do first is I have their API requires a key. So I have a key, which I'm not showing you because I don't want you to copy it. And now I'm going to write an action. Now there's a few things different about this action. First of all, you'll see that this action accepts a parameter of a username. And this is how we're going to pass data from our URL or our URI into the action. And you'll see that later in the router. The second thing you'll see is we're using this cached action here. And with this cached action, we pass our actual action implementation into it. And this is an example of action composition in Play. So you can compose many actions together. So you might have a login action, you might have a authenticating action, and many other sorts of things. So this is just an example of that. We're using cached today because I don't want to be hammering Clout. And this just caches the result against a certain key for 120 seconds. So, implementing this, we're going to use the play. We're going to do an asynchronous call. So the result of our call will be a feature of result, and then we're going to wrap this in the async result. So what we want eventually after doing this is a feature of result. And so this is a demonstration of how Play does async I/O without blocking. So to make the call, we're using the Play WS API. WS stands for Web Service. So we have a URL there, which we're looking up based on a query parameter. We're looking up the identity of a user based on their Twitter name. So here I'm passing some query string parameters. So screen name, so that's my Twitter name, is the username, which comes from the URL, and the clout key. Now I can invoke get, and this invokes the HTTP get root method. And if you actually have a look there, the result here is future of response, response being the response from the WS call, but we need a future of a result. So we need to convert the WS response to our play result. But before we do that, I actually need to make two calls on Clout, because all this gives me back is an ID for a user based on their Twitter name. I actually want their score, so I need to make a second call to look up the score using that ID. So to do that, I'm going to use the flat map method. And so flat map, when it comes to futures, basically means and then. So once I've got my result, and you can see I've got my response object here. Now I'm going to check that lookup was actually successful. If it wasn't, I'm going to return. Everybody turn their mobile phones off. If it wasn't, then I'm just going to return a score of 0. But if it was, then I will extract the ID out of the response, and then I can make the next call, which goes and looks up the score of that ID, again passing a query parameter and invoking get to do the method. And at this point, again, I have a future of response, but what I want is a future of result. So all I have to do is map that to a result. And I'm just passing back the JSON as is to the end user. And that's the implementation of our influence action. So we need a route for that. And here you can see that I've passed parameterized the URI with a username parameter, and then I can look up the influence for that username, and then I can pass that parameter into the influence method. So now we've got our influence route. Let's use that. So I'm now going to write some JavaScript to load this asynchronously when the page loads. Now I could just write ordinary JavaScript, but again, because I can, I'm going to demonstrate Play's integration with CoffeeScript. So
with the async stuff,
yep.
For the browser experience, it's still going to have to wait the full time until the full result
Yes,
comes back.
that's right.
That's just from the play. It doesn't use as many threads. That's the
That's right. So here I've created a CoffeeScript file, and if I were to have a compile error again, Play will kindly tell me about it. So I'm not going to go into detail about the CoffeeScript that I'm writing, because this isn't a CoffeeScript user group. But basically, I'm going and finding all of the usernames on the screen that don't yet have an influence attached to them, and doing a call back to the Play server to look up that user's influence, and when that comes back, appending that to the element to show what their influence is. And I'm going to do that when the window is ready. So now, we've also got to include that script in our application. Again, you can see using the reverse router there, this time to look up assets. So if I was to change the URL that assets were served at, that would really help there. And in fact, this is very useful for things like using a CDN versus not using a CDN in development. Okay, so if my internet connection is working and Clout is happy, then we should get a Clout score on here. But so far we're not. Why not?
it's going too smoothly.
Where's Did I name it incorrectly? Ah, I called this directory the wrong thing. Refactor, rename, JavaScripts.
If only directory names for Typesafe.
And this time you can see it's worked. So my influence is 57. Let's try it with someone else. How about with nobody? Nobody doesn't like this presentation. So there we can see nobody has more influence than I do. Okay, so now we've seen some of Play's asynchronous capabilities. Why don't we move on to some even more crazy new web standards? We're going to turn this into a rich application using WebSockets. So to start off with, I'll write a WebSocket action. Okay, so when writing WebSockets, WebSockets basically are just streams, full duplex streams to and from the browser. So Play uses iteratees for its asynchronous streaming, and iteratees are basically consumers. Anybody here come across iteratees before? Okay, so a few people. Iteratees are consumers, and the producer equivalent is called a numerator. You don't really have to worry about the details of iteratees or how to use them because Play provides the right helpers for you. But in our case, what we need is a broadcast enumerator, because when somebody posts feedback, we want to broadcast that to all the other users that are connected so they can see that immediately. So we're using this concurrent.broadcast that returns an enumerator and that we can then use to send to all the updates to all the users, and it also returns a channel for pushing the broadcasts, the broadcast events into. I've also the type of this enumerator is JS value, so it's producing JSON, and I've declared a rights for my feedback class so that feedback can be serialized to JSON. Now this is actually a Scala macro that takes the feedback case class at compile time and generates code somewhat similar to the sort of code we see up here with the feedback form that maps it from a case class to a JSON object. You can write this manually. The syntax is not too bad, but we've got the Scala macro there that makes it very nice.
Which JSON library is it using?
It uses the JS value is a play thing, so you only ever interact with the play classes. Underneath, it's using Jackson to do the generation of the JSON and parsing of the JSON.
So you had some other code that was using a different JSON library. How easy would it be to integrate it?
It wouldn't be hard. So there's nothing Jackson specific about the data types. So the things that convert a case class to a JS value tree, there's nothing Jackson specific there. It's only when we go to convert the JS value tree into actual JSON or read JSON from a JS value, or read a JS value tree from actual JSON, that we're using Jackson. So yeah, you can, as long as you can define a way to convert that JS value into whatever the other library wants, it should be fine. So now we're going to write our WebSocket action. So you can see instead of this time using action, we're using WebSocket, and this is a WebSocket that uses JS values. Now for the consumer, so the iteratee, we're using this for each iteratee, and we're actually just ignoring everything for now. And the producer, we're sending our broadcast enumerator. Now we need to actually publish when somebody leaves feedback to that broadcast enumerator. So let's do that now. And so this is actually where the rights get used. There's an implicit value on that implicit parameter on that toJSON call that takes the rights to convert our feedback into a JS value. Okay, now we need our routes. And so this is going to map the feed URL to our WebSocket action. And the final thing we need to do is a bit more CoffeeScript. So we're going to create a new WebSocket there. We could use the reverse router there, by the way. I'm not, just because I'm not generating my CoffeeScript with anything at the moment. And we want to handle the messages. So when we get a WebSocket message, we're going to parse it and then append it into our list of feedback. And we're also going to update influence at the end to go and load everybody's influence. So now, if we refresh this, it should connect to a WebSocket. And I've got another window here. And so if I leave some feedback, we should see it appear immediately in the other browser. So the final thing that we're going to try and do is we're still submitting the form using an ordinary post, but we want it to be a rich application that everything is on one page. So we're going to use WebSockets to submit the feedback. So we'll go to our action, and where we were ignoring the messages coming in, we're going to again reuse our feedback form. So an interesting thing with the form API in play is that it can actually be used to bind JSON, and we won't worry about errors for now, but we're going to insert it and then push it again. And now we just need to write some CoffeeScript to hijack the form submit. So when a form is submitted, we will send the serialize the form to JSON and send it to the WebSocket and return false, so it doesn't actually end up submitting the form. And now we can try again.
So what's the advantage of doing it via WebSocket rather than the form submit?
I guess in this case there's not much of a difference. If you had a rich application where your page had a lot of state that's dynamically rendered and you just wanted to submit a small thing on the side and have that and not lose the whole state of the page, then so for example, I mean, if you're writing a real-time, something like Google Docs, you don't want to do a whole page submission there, so you can have a stream there where you're just sending updates as they happen. And so that time there was no page refresh, it was submitted using the WebSocket. So that's all I had. We can switch back to the presentation.